way the universe began, and everybody always asks, how did the Big Bang begin and what happened before that? And philosophers, theologians, physicists now begin to speculate on it. I really come to you because you have some very unique insights.
There's something almost paradoxical about this microwave background. It's telling us that there was something like the Big Bang there, but it's also telling us, because the observations of you can plot the frequency, you can plot the intensity against each frequency, and you find this wonderful curve. It's the curve, black body spectrum, and it agrees with that to an extraordinary precision, much better than you could produce in the lab. And this is telling us that the very early universe must have been in what's called thermal equilibrium. By definition, is the maximum random state. It's the state that the second law tells us we're going to get in the future, if you like. But there it is in the past. So why is it that the very special state has to have been there at the beginning, otherwise we don't have a second law?
Scientists were taken by surprise when they encountered an enigmatic entity that has been present since the early stages of the universe. Thanks to the advanced capabilities of the James Webb Space Telescope, which successfully captured images of this elusive phenomenon, researchers have identified a black hole located near the outer limits of the cosmos, subsequent to the detection of the oldest known galaxy. Based on observations made with the James Webb Space Telescope, it has been determined that this supermassive black hole, boasting a mass 10 million times that of the Sun, exhibits vigorous activity and is actively growing as it consumes surrounding matter from space. This raises intriguing questions about why this colossal black hole positioned at the edge of the universe is both captivating and alarming. What's interesting is that famous physicist Roger Penrose has made a concerning announcement about this black hole. Let's uncover the mystery of this black hole and what Roger Penrose has to say. The estimated time for the emergence of the first stars and galaxies in the 13.8 billion-year-old universe is believed to be within the initial 400 million years. However, the exact moment when the universe first lit up with starry lights remains uncertain. A primary objective of the James Webb Space Telescope, JWST, which was launched on December 25, 2021, is to precisely determine when this great illumination occurred during that ancient era. Since its deployment and activation in the summer of 2022, the JWST has been actively observing the cosmos. Recently, the telescope captured a stunning glimpse into the past, spanning a remarkable 13.4 billion years. In an exciting discovery, an international team of 80 astronomers from 10 different countries, using the powerful JWST, identified the 4 oldest galaxies ever observed. Among them is a galaxy that formed a mere 320 million years after the Big Bang, when the universe was only 2% of its current age. To put this in perspective, our Earth and solar system are approximately 4.5 billion years old. The team concentrated the observational efforts of the Webb telescope, the most advanced space observatory to date, on a relatively small region of the sky. In doing so, they were able to capture the faint light emitted by these ancient galaxies. The resulting image, although appearing to show a human-sized area from a distance, is actually teeming with nearly 100,000 galaxies, each frozen in time billions of years ago. The discovery of these early galaxies through such exquisitely beautiful photographs is a remarkable achievement. The 4 ancient galaxies were identified within the Hubble Space Telescope's AST Ultra Deep Field, a small but densely populated area of the sky containing an estimated 100,000 galaxies. For over 2 decades, the Hubble telescope has explored this deep field, but its observations were limited due to the visible spectrum it primarily detects. A phenomenon called redshift causes the light from distant objects to shift towards the infrared spectrum, which is invisible to Hubble and the human eye. However, the Webb telescope can detect this infrared radiation, enabling the detection of particularly old galaxies and stars. During 10 days of observation, the team utilized the Webb telescope's near-infrared camera, NERCM, to scan the deep field region, resulting in the discovery of the 4 galaxies. Analysis of their redshift values revealed that these are the oldest galaxies ever observed, with ages ranging from 320 to 350 million years after the Big Bang. Determining the ancient nature of galaxies involves more than just redshift measurements. They're so crucial. Heavy elements and metals, such as oxygen, carbon, and nitrogen, were not yet formed in the early universe, since they are produced in supernova explosions of young stars, which had not yet come into existence. The primordial recipe of the universe primarily consisted of hydrogen and helium. Therefore, a galaxy can be identified as truly ancient if it exhibits an extreme redshift and lacks heavy elements and metals. To support their conclusions, the astronomers employed another Webb instrument, the Near-Infrared Spectrograph, NIOSPEC, to examine the chemical signatures of the galaxies. The results confirmed that these galaxies were primarily composed of hydrogen and helium, further affirming their status as the earliest and oldest galaxies ever observed. The weak infrared spectra captured during 28 hours of observation over 3 days are unprecedented. This achievement not only contributes to scientific research, but also provides evidence that millions of stars illuminated the universe 13.4 billion years ago, laying the foundation for the formation of the earliest planets. It's important to note that while these 4 recently discovered galaxies are currently the oldest known, they do not represent the absolute oldest galaxies in existence. The James Webb Space Telescope is designed to explore the deepest reaches of space, providing unprecedented insights into the early universe. Furthermore, the telescope is also capable of observing fascinating worlds within our own galaxy and even planets within our solar system. In addition to these discoveries, the James Webb Space Telescope has detected an active supermassive black hole, which is 10 million times larger than the Sun. This black hole is actively growing by consuming matter from its surroundings. It is the earliest developing supermassive black hole found to date, forming only 570 million years after the Big Bang. However, researchers anticipate that more discoveries will follow, potentially surpassing this record. The black hole was found within one of the earliest discovered galaxies, formerly known as EGSC 8P7, and now referred to as CEERS 1019. This finding offers insights into one of the biggest mysteries of the early universe: how black holes in the cosmic dawn rapidly grow to enormous sizes in a short period. Larson, one of the researchers involved, describes this discovery as the farthest active galactic nucleus, AGN, and earliest black hole ever detected. Initially, Larson examined CEERS 1019 while studying the light emitted by star formation in the early universe. This light, known as Lyman alpha emission, is thought to arise from the ionization of neutral hydrogen due to star formation. In the early universe, light couldn't travel far because of a cloud of neutral hydrogen. It was only after the ionization of this hydrogen that light could freely traverse the cosmos. The epoch of reionization, which remains an area of significant research, occurred within the first billion years after the Big Bang, which took place 13.8 billion years ago. CEERS 1019 and a few other early galaxies, which are relatively bright, serve as valuable research targets for studying this period. CEERS 1019 was first detected in Hubble data back in 2015 and was the oldest and farthest galaxy observed at that time. However, due to the redshift caused by the expansion of the universe, the earliest light has shifted into the infrared part of the spectrum, requiring a powerful and specialized infrared instrument like the JWST to study these objects. While subsequent observations confirmed the existence of CEERS 1019, detailed information remained limited. Hence, when the JWST became available, CEERS 1019, being one of the brightest Hubble galaxies from that era, became an obvious target. All 4 of the JWST's instruments were directed towards this galaxy for an hour. The observations yielded a wealth of information, but researchers unexpectedly discovered a broad emission signature typically associated with AGN. This finding piqued their interest, leading to discussions with AGN researchers. In the early universe, galaxies generally emit either AGN light or light from star formation, making the presence of both in the same galaxy highly unusual. Normally, one would expect either one or the other. Although the black hole has some influence on the observed emission lines, the majority of the light in the photo still originates from the galaxy's star-forming region. While it may seem surprising to observe a supermassive black hole expanding more than 13.2 billion years ago in the early universe, much larger black holes have been discovered, such as J1000, 342 plus 928, a quasar galaxy detected 690 million years after the Big Bang. housing a supermassive black hole estimated to have a mass of 800 million suns. The black hole in J0313 plus 1806, with a mass of 1.6 billion suns, formed 670 million years after the Big Bang. Both of these quasars are dominated by AGN radiation. CER's 1019, according to Larson and her colleagues, seems to represent the transitional stage between these later, larger AGN-dominated galaxies and the initial formation of galaxies and their black holes. The researchers believe that the supermassive black hole in CER's 1019 was formed through the collapse of a large object, possibly one of the first stars in the universe. Since these stars were much larger than those in our present vicinity, the black hole resulting from their collapse would have had a head start in becoming supermassive. However, it still required assistance, which may have come in the form of repeated super-Eddington accretion. The Eddington limit refers to the maximum sustainable rate at which black holes can grow. A black hole is surrounded by a disk of material that feeds into it, similar to water going down a drain. When the material exceeds the Eddington limit, it moves too quickly and escapes into space rather than orbiting the black hole. Although super-Eddington accretion is only feasible for short periods, simulations suggest that it may have occurred in bursts, aiding the expansion of the black hole at the core of CER's 1019. So that seems enough for this video. Thanks for watching, and stay tuned.